If you're interested in trying to learn the skills for excellence for the right angle triangle, I'm going to explain a little bit about how to generalize using Pythagoras and trigonometry. So here is a right angle triangle, and we know two of the sides. They're called M and N, so we don't have the exact values. We're just trying to get the relationship between these two sides and the hypotenuse. So we know that the hypotenuse squared equals the sum of the squares of the other two sides. So I'm going to call this one x. So x squared equals m squared plus n squared. So if we rearrange a little bit, we can take the square root of m squared and n squared. So we now have a generalized formula to find the hypotenuse length. It's the square root of the sum of the other two squares. So it looks a bit funny, but this will apply for all right angled triangles. This is exactly the same triangle as this. I've taken away the n because I actually want to show you how to substitute using something that looks a little bit funny. Still works exactly the same way. So I'm going to put our value for x over here. So now we use SOHCAHTOA to be able to find the angle. We label the sides between the 90 and the known angle, the adjacent, opposite the long side, the hypotenuse. So we know it is ka from SOHCAHTOA, and we know from our triangle, cos, the angle, I'm just going to call it y for now. It's going to, up here, A, the M, the hypotenuse, bottom right corner, the ugly looking thing. Okay, we just use exactly the same process as we've used before. Cos y, covered up, the m above the square root. Rearrange slightly to find the angle. So it works exactly the same way as what we've done before when using numbers and trying to find exact solutions. We now just have a generalized formula that will apply for all right angled triangles when we're trying to find the angle and we've got an adjacent and a hypotenuse side.